This is a video from the Exam 1 review in my Calculus 2. Let's take a look at problem 1. Suppose we have the integral from 1 to 2 of x over x plus 1 squared dx. So what I want to do to attack this problem is I'm going to add 1 and subtract 1 in the numerator. Because when you add 1 and subtract 1 in the numerator, that's like adding 0. And I don't change anything about the integrand. And from here, I want to split up that integrand. And so I get the following. So on this line, I get the integral from 1 to 2 of x plus 1 over x plus 1 squared minus 1 over x plus 1 squared. But this is the integral from 1 to 2 of 1 over x plus 1 minus 1 over x plus 1 squared. But this is the natural log of the absolute value of x plus 1 plus 1 over x plus 1 evaluated from 1 to 2. If I put 2 in for x, I get natural log of 3 plus a third. Then I'm going to go minus, and then I'm going to replace x with 1 to get natural log of 2 plus 1 half. Right here. So I'm going to distribute that negative inside to each term within the parentheses. And when I do, I'm going to get natural log of 3 minus natural log of 2 plus 1/3 minus a half. And so you notice off to the side, I just wanted to quickly figure out 1/3 minus a half. 1/3 minus a half is negative 1/6. And so from here, I get natural log of 3 over 2 using properties of logs, and then I just subtract off 1/6. And that's the answer to problem 1 on the review. Let's take a look at problem 2. Suppose we have the integral from 0 to pi over 6 of t sine of 2t dt. So this is classic integration by parts. I'm going to let u equal t, and I'm going to let dv be sine of 2t dt. du is 1 dt, and v is negative 1/2 cosine of 2t. And so this is equal to negative 1/2 t cosine of 2t, and this is evaluated from 0 up to pi over 6. That's the first part. That's my uv. Then I'm going to go plus, because I'm subtracting a negative. And then it's 1/2 the integral from 0 to pi over 6, right, of essentially v du. Now, the 1/2 is on the outside of the integral, and then I'm going to integrate cosine of 2t dt, like this. Now, replace t with pi over 6. So you get negative 1/2 times pi over 6 cosine of pi over 3. If I take pi over 6 and double it, I get pi over 3. Then I'm going to go minus, and then when I replace t with 0, I get 0. Doesn't matter about the rest. Then I'm going to go plus 1/2 of 1/2 sine 2t, evaluated from 0 to pi over 6. Now, we just got to step through this a little carefully, right? Now, cosine of pi over 3 is 1/2. So this is negative pi over 12 times 1/2, right? Then I'm going to go plus 1/4 times sine of 2t evaluated from 0 up to pi over, let's check, pi over 6. Okay, so this is negative pi over 24 plus 1/4 of, and then I'm going to take sine of 2 pi over 6, right? If I take pi over 6 and double it, I get pi over 3. And then I'm going to subtract off sine of 0. Now, this is negative pi over 4, negative pi over 24 plus 1/4 of. Now, sine of 0 is 0. Sine of pi over 3 is square root of 3 over 2. Okay? So this is square root of 3 over 8, right? 2 times 4 is 8, minus pi divided by 24. And that's how we do problem number 2. Let's take a look at problem number 3. Suppose we have the integral of 1 over 2t squared plus 3t plus 1 dt. And so this is the integral of 1 over 2t plus 1 times t plus 1 dt. So this is classic partial fraction decomposition. So I start with the left side here, and let me specify. My left side is 1 over 2t plus 1 times t plus 1. And I want to split this up into a over 2t plus 1 plus b over t plus 1. Okay. Now, what is my LCD? My LCD is t plus 1 times 2t plus 1. And I'm going to multiply both sides by that LCD. And when I do, I get 1 equals a times t plus 1 plus b times 2t plus 1, like this. So 1 equals at plus a plus, now I want you to notice, I'm going to distribute the b inside to each term, just like I did the a, right? And then I'm going to get 2bt plus b. Do we agree? Now, 1 equals, I'm going to combine these terms together and factor out the t. So I get a plus 2b times t plus a plus b. Just like this. Now, I have a t equation and I have a t to the 0 equation. And so from here, I get a plus 2b. That has no choice but to be 0. Think about balancing a chemical equation. And then a plus b has to equal 1. Now, if I subtract these equations, are we in agreement that b, right? If I subtract, the a's cancel, and I have b equals negative 1. And if b equals negative 1, that's going to force a into being 2. And so let's come over here. I have the integral of 1 over 2t squared plus 3t plus 1 dt. this is the integral of 1 over 2t plus 1 times t plus 1 dt. This is the integral of, now let's remind ourselves, a went with the 2t plus 1. So I'm going to get a over 2t plus 1 plus b over t plus 1 dt. But what was a? A was 2. B was negative 1. So I get 2 over 2t plus 1, right, minus 1 over t plus 1 dt. And I'm done, right? Because I want you to pay attention to something here. Isn't the derivative of the denominator for that first term the numerator? That's exactly what I want, because the integral will be natural log of that denominator immediately, okay? Then I'm going to go minus natural log of t plus 1, and then I'm going to add c. And you get there, I'm pretty happy, okay? And that's how you do problem number 3. Let's take a look at problem number 4. Suppose I have the integral from 1 up to 2 of x to the 5th natural log of x dx. Classic integration by parts. But remember our little magic mnemonic, right? This is the pecking order. Liate or liate or something, right? L stands for logs. So in the pecking order, that's what I'm going to call u, is natural log of x. My dv is x to the 5th dx. Again, classic integration by parts problem, okay? Now, from here, du is 1 over x dx. My v is 1/6 x to the 6th. So this is 1/6 x to the 6th natural log of x evaluated from 1 to 2. So I want to see that vertical bar. This is when we do integration by parts. That's my uv. So when you have a definite integral, it needs to look like this. And I'm going to go minus. I'm going to pull that 1/6 out in front. I'm going to integrate from 1 to 2. Do not ignore the limits, okay? And then I'm going to get 1 over x times x to the 6th dx. If I pop that 2 in, remember, 2 to the 6th is 64. So I get 64 over 6 natural log of 2. And remember, natural log of 1 is 0, so I don't have to worry about that lower limit. And so I'm going to go minus 1/6, the integral from 1 to 2, of x to the 5th dx. Now, if I reduce 64/6, I get 32 over 3. Natural log of 2. Minus 1/6 of. Now, the integral of x to the 5th dx is 1/6 x to the 6th. And I'm going to evaluate from 1 up to 2. So this is 32/3 minus 1 over 36, right? Because that's what 1/6 times 1/6 is. And then I'm going to get 2 to the 6th if I replace x with 2 minus 1. But that's 63 inside the parentheses here. So that's 32/3. Oh, and then what did I forget? don't forget that natural log. Right? So I'm going to get 32 thirds natural log of 2 minus. And then I'm going to get 63 divided by 36 here. Now, if I divide the numerator and denominator by 9, I get 32 thirds natural log of 2 minus 7 over 4. And that's how we do example 4. And that's a good stopping point for this video. This is a video on the Exam 1 review, and we did problems 1 through 4. Thank you.